Hey guys, welcome to another video. What I have here is a 3D printed helicopter which I have designed from scratch. As you can see, the rotor head system is 3D printed. The swatch plate is also 3D printed. Majority of the parts is actually 3D printed. You get to see the build process in this video. And to talk about this RC helicopter, I decided to do a couple of things that it's just slightly different from a conventional 3D printed RC helicopter. For example, I have an onboard gyro system which is actually meant for a fixed wing models. But I decided to use it on this RC helicopter project just to experiment to see if we can actually use the same gyro system for an RC helicopter project. So I have two separate gyros here, one for the pitch and roll axis, and and I also have for the tails rotor system as well. There's a couple of changes on this model because as you can see, I mean, you get to see it along the video why I changed a couple of things like the motors and the tail motor too as well because of one or two issues that we experienced along the way. So before we continue, make sure you like this video, make sure you hit the subscribe button and as well as hitting your notification bell so that I don't miss out the new video and a couple of upgrades that I'll be doing later to this project. And also, I'll be leaving some links to where to get some of the components that I used, and as well as the files for the 3D printed parts as well. Let's get started.
All right, so starting with the airframe, so this is the designed airframe that holds pretty much every component on the RC helicopter. And from the airframe, we went ahead to design the swatch plate. So the swatch plate consists of four major components: the upper plates, lower plates, the ball, and as well as the bearing. As you can see, the upper plate is designed into two components so that you are able to install the ball and seal the upper plate together with two screws. You can probably use some super glue to permanently hold it together, but you need to be careful with that. The next thing on the line is the tail boom. It's pretty much a 8 millimeter carbon fiber rod of about 325 millimeter in length. And here is the rotor head system. The rotor head system is consists of three components. As you can see, there is a 30 millimeter steel rod at the center that creates the pivoting point for the rotor head. And I have designed the rotor head to split into two before assembling everything all together, so as to allow the rotor heads to move freely about the pivot point. So, and also there's a support for the linkage system, as you can see below the rotor head as well. So that's pretty much everything for the rotor head system. All right, so here's the landing gear. The landing gear is just two main landing gears that I connected with carbon fiber rods. And as you can see, I added some ribs to further reinforce the landing gear from all the stress from the landing and takeoffs. And also you can see the two screws O that I've attached to as well. That is used to fasten the landing gear to the airframe. The tail motor mount is pretty much a basic design. It's a single body that holds the tail motor as well. And I added a tail fin to support to protect the prop from striking the ground and also to create some sort of directional stability. Yeah, so this is the rotor head system with the linkage rod connected. As you can see, this is a 2 millimeter ball and socket joint, and this is one of the non-3D printed components that I've used. So it's basically connecting the upper plate of the swatch plates to the rotor head system to create um, the tilting motion from the servos. So the servo tilts the lower plates and translates that to the upper plate, which translates that to the rotor head system. And here about the fuselage, the motor area is designed to have slotted holes so as to create some adjustments for a couple of different motor sizes just for experimental purposes. So that's pretty much everything about the airframe. So let's get started and let's start reprinting. Yeah, here's the fully 3D printed airframe. As you can see, it came out pretty well. This is after trimming all the supports and the brims around it. Pretty happy with the way it turns out. Of course, there was a couple of failed prints. As you know, printing with ABS filament can be very difficult. And this is the P1 3-axis gyro that I'll be using for the roll and pitch axis for stabilization. Alright, it is time to make the swash plates. As you can see, the swash plates components are ready. I have the upper plate splitted into two parts so as to create a ball and socket joint, which is what the ball is actually going to be used for. The lower plate and the upper plate will be connected together via the bearing so that the upper plate moves freely while the lower plate remains stationary. So let's get started. The swash plate has been fully put together. All that is left is just the linkage assembly. As you can see, the ball in the center is moving freely. This is because of the ball and socket effects that is happening in the upper plate. And you might want to use some super glue to reinforce the joints before putting the upper plate together, and as well as the upper plates between the upper plate and the bearing. But make sure not to get the super glue into the bearing so that it doesn't damage the bearing. So other than that, the swash plate is almost ready. All right, the upper plate has received the linkage assembly. It's a ball and socket linkage rod, which I'll be leaving the link in the video description, so do make sure to check it out. If you're still watching this video and you haven't subscribed, make sure you hit that subscribe button and hit that notification bell, and let us continue. These are the components for the rotor head assembly. The rotor head itself, the steel rod, and as well as the T-shaped connecting brackets. The steel rod is about 30 mm in length and 3 mm in diameter. It sits perfectly in the slots for the lower part of the rotor head. So when the upper plate is glued to the lower part of the rotor head, it creates a pivoting point for the rotor head. So you need to make sure to put super glue in the necessary places, avoiding the steel rod so that it doesn't get stuck. Because the whole point is for the rotor head to be able to tilt about the pivot point. So here's me clipping it together for a test fit before using super glue to actually glue it together. It is time to start assembling all the components together. This is the main airframe, and the main airframe is in two components. The main one and the other one just serve as a cover for the main unit. So as you can see, I've pre-installed the bearing for the main rotor shaft. This is the main gear. It's about 80 millimeter in diameter. Of course, this is the swash plates that we've pretty much put together. This is the rotor head system. It's pretty much basic. And this is the main rotor shaft. Now we have the motors and the servo installed on the main airframe. We'll go ahead and install the side airframe so as to complete the assembly and make it more rigid. After putting together the main airframe, I decided to change the motor pinion gear to a brass pinion gear. I previously had a plastic pinion gear, but there was a lot of slippage and grinding from that previous pinion gear. So I'll be linking the rotor edge system and the swash plates with the linkage rod. So the linkage rod will be made with the 2 mm ball and socket connector, which we'll show you in a couple of seconds here. And I will be connecting this ball and socket connector or joint with a 2 mm threaded rod so as to create a rigid link between the two of them. What I'm trying to do here is to do a test fit for the rotor head where the ball and socket joint is going to attach to on the rotor head. So I'll also be using an hexagonal 2 mm screw to attach it to the rotor head unit. And then after that, I'm going to connect the ball and socket joint together using the threaded rod. This is the assembled linkage rod, and as you can see, what I've done here is to use an M2 threaded rod by cutting off the main head of the threaded rod to connect the ball and socket connector parts together. You can also use a desired length depending on how tall your rotor head is or the spacing between your swash plate and your rotor head. So it's easy to adjust the length to as well. So what I'm doing here now is to connect the linkage rod to the rotor head and connect it to the upper part of the swash plate. Now that the linkage rod has been attached to the swash plate and the rotor head, I've basically installed it on the main rotor shaft. And clearly you can see that there's a twist between the swash plate and the rotor head. So this requires a supporting bracket to hold the linkage rod in a straight position. The support for the swash plate has been 3D printed, and you can see it's holding the linkage rod in place. And also it doesn't stop the linkage rod from translating the swash plate to the rotor head. And also I 3D printed the support for the lower plate. Right, it's time to install the landing gear, and at the base of the frame I have inserted 4 insert nuts to the base, and I'll be using a couple of M3 screws to attach the landing gear to it. After installing the landing gear, the servo was linked to the lower part of the swash plate with the same 2 mm ball and socket joint. This is the tail motor mount. I've already installed the motor with a couple of screws at the back. It's a single body and it's still printed with ABS filaments. The motor I have here is a Raystar 1806 2300 kV motor. All the links will be in the video description along with the specifications.
Managed to put all the electronics on the helicopter. As you can see, I have two gyro installed. This is for the tail gyro, and there's a gyro here that's for the roll and pitch axis. So I've also configured the um, roll and pitch gyro to correct for stabilization, as you can see. Yeah, so pretty much the ESC for the tail rotor, I'm here to configure this. Uh, and also the main ESC is zip tied to this portion here as well. I mean, there's a bunch of cable hanging around, but this is as tidy as I could do it. I don't know if they're probably going to be useful for something else in the future. So yeah, so this is pretty much it.
All right, for the last couple of flights that I did, there's a couple of things that I noticed from the flight. So around my swash plate area and my control linkages, there was a lot of play and a lot of travel limits. This is because the ball and socket joint close to the rotor head system doesn't have enough spacing. So there's a limit to how much the servo can travel for the linkage system. So I decided to add a little bit of a small 2 millimeter knot to create a space between the ball and the rotor head spacing, and I also added it for some of the spots on the lower plates too as well. I also reduced the tolerance for the swash plate stopper. This is the uh, plate support for the battery, so that I can extend the battery forward to compensate for the center of gravity. I also extended the servo arms to make it more responsive to little movement from the gyro, because the stabilization wasn't really up to par when I was trying to fly it. So I increased the arms for both the roll and the pitch axis to get more authority from the small movements that I get from the servo. So that's pretty much the upgrades.
What did I break? Ah, I don't break my landing gear.
Oh my god. Oh wow. It's starting to wiggle. Why is it wiggling? I think it's the stabilization. I don't know why. I don't know why it likes to wiggle after some time. I don't know why it's doing that. Okay. Dancing. Dancing on the pitch axis. So this is without stabilization and it's dancing around, okay? Alright, so I've maxed out all the gyro sensitivity. Let's see how the aircraft is going to behave now. See, it's wobbling, but it's still cycling about. It's too much. You are too close, move back. Oh wow. Oh, it's starting to wiggle around. It's starting to wiggle again.
There was an improvement after the changes I made, but however, I'm having difficulty in maintaining a hover position. The helicopter seems to move in a circular pattern. So if you guys know why the helicopter is behaving in this manner, kindly let me know in the comment section below. I'd appreciate your feedback. Also, I notice I'm not getting enough lift based on the throttle inputs that I'm giving. So I'll definitely be getting a higher RPM motor to see the potential of what a higher RPM motor is going to give us based on the lift. Perhaps that will also improve the flight performance for the helicopter. If you're still watching this video, make sure you hit that subscribe button and hit that notification bell so that you don't miss out when I put out a new video. Thank you for watching.